Hi guys, good morning. Hello. Yes guys, good
Yes, sir.
morning.
Good morning. Good
Hear
morning,
me?
sir.
Yeah, thank you. Let us start session.
Good morning, sir.
Yeah, thank you. So let us start session. Yeah, today my throat is fine. So well and good. Let us continue session. Let's start. Yeah. Yes, today I can explain better than yesterday. Yes, throat is fine. Now let us continue session. Yes, last class about these basics discussed, like system software, application software. Next about OS discussed. Next about front end, back end discussed. Next about languages and packages discussed. Next about low level, high level languages, software languages. Yes, even generation of computers also discussed. Okay. Yes, low level, high level languages, these things discussed. Yes, today we should discuss about yes, interpreter and compiler. The differences we should discuss. Okay. Yes. Yeah, these basics are very important. Okay. Yes, even some guys are having 10 years of experience, or they don't know about these kind of basics. There are some unknown facts. Yes, you must have that knowledge here. See, let us see about interpreter and compiler. Yes, today topic is interpreter versus compiler. One second. Close this down. Yes, today topic is about yes, interpreter versus compiler. Interpreter versus compiler. Today topic. Yes, interpreter and compiler. Interpreter and compiler both are to convert from high level language to binary code. But there is a difference here. There is a difference between interpreter and compiler. Both are to convert. Interpreter and compiler both are to convert. Interpreter and compiler both are to convert from high level language to binary code. See, interpreter or compiler. Okay. See, interpreter or compiler convert from high level language to binary code. High level language to binary code. Both are to convert from high level language to binary code. Okay, both are to convert from high level language to binary code, but some difference. What's the difference here? Let us see the difference today. Interpreter versus compiler. Yes, for interpreter. First, let us take some interpreter here. Yes, interpreter. For this purpose, I'm taking Python scripting. Python is a interpreter based language. I'm taking Python for this. Python. About test.py file. Some Python scripting. I'm taking some Python scripting. Yes. Python scripting. To develop the Python scripting, we can use PyCharm. This is a PyCharm ID. Okay, for Python purpose, PyCharm ID is available. Okay, now it's very simple script I'm developing. So why going for ID is not necessary. Just we'll go with the Notepad. Very simple script I'm developing here. Very simple script. Now let us go with the Notepad. Okay, Notepad. See D drive. Suppose let us take some sample folder. Okay. Yes, sample folder. Yes, sample folder. Why is not clear? Giri Kishore. Yes, I think. Yes, can you hear me? All of this. My voice is it clear? Hello. Yes, is it clear? My voice? Yeah, fine. Thank you. Giri Kishore, just you try to rejoin. If not clear, just rejoin. Maybe check your network connectivity also. Check your network connectivity also. Some network may be issue. Yes. See D drive sample folder. The D drive sample folder. Here this folder, in this folder, let us develop a script here. Python script. Python script. See, first of all, command prompt. Go to command prompt. Open command prompt. Yes, D drive. We should go to D drive. So D colon, it's a D drive. DER that contains. Here it's a sample folder. Sample directory. Sample directory. Directory. DER means directory. Sample directory. Directory folder both are same. Yes, in GUI calling as folder, it's a folder. In GUI folder, same thing, character interface. Character interface calling as directory. Character interface is directory. Yes, in GUI it's a folder. Okay. Yes, now here CD change of directory to sample. Change of directory sample change to. So let's clear the screen. DR it is. Sample directory contains nothing, empty. Yes, 0 files. This is empty. It contains nothing here, 0 files. Okay. Sample directory. Yes, in this. Yes. How interpreter working? Let us say about Python script. Today topic is interpreter versus compiler. Today topic is interpreter versus compiler. First, let us see about interpreter. For this example, I am taking Python. For this example, Python scripting. Python scripting. Python scripting. See. Notepad. Yes. Test.py. Notepad test.py. Python script. Yes, cannot find test.py file. Do you want to create a new file? Yes. Cannot find. Do you want to create? Say yes. Now creating. It's a simple, very simple script here. A is equal to 10. Okay, A is equal to 10. Yes, B is equal to 20. Very simple script I am writing here. C equal to A plus B. C equal to A plus B. Yes, print. Yes, addition. Yes, print addition. Addition is equal to C, displaying C value. Addition. Okay. Next subtraction. Next multiplication. Addition. Next subtraction. Yes, subtraction. Subtraction. Next multiplication. Next multiplication. Multiplication. So this is simple program. Program to add, subtract, and multiply two numbers. Very simple script. For understanding purpose, taken a very simple script. Yes, save, control yes, notepad save, control yes, saved, and exit. Okay. Yes, now DR. Yes, sorry, CLS, DR. See, test.py script developed. Test.py, 9:27 AM. Yes, 36. Today 30th. Now 30th June, 9:27. Test.py. Now submitting this script. Python test.py. Okay, run it. Yes, got the output. Got the outputs. Okay, directly execute it. Suppose if it is C program, first of all you have to compile it, right? In C program, first you have to compile it. If no compilation error, then running. If it is C program, first of all you have to check for errors. If no errors, then executing. But Python script, what happens here? No errors checking, nothing, directly executing. Python script will execute directly. Yes, it's interpreter. Interpreter will execute the script directly. Yes, it won't check for any errors. Initially, it won't check for errors. Directly executing. Directly executing. Directly executing. Okay. So interpreter executes the program directly. Directly executing here. No errors checking, nothing. It won't check for any errors. Interpreter does not check for errors here. So executing directly. Suppose any error comes, what happens? If any error comes, what happens? Let us see. If any error comes, what happens? See. Now some mistakes. Suppose comma missing. Okay. Here some bracket missing. Here some double quotation missing. Save. Save. There are 3 errors here. This is one error. This is another error. Total 3 errors. 3 errors. Now what happens here? Totally 3 errors. 3 errors. Now what happens? See. Now Python script running. Directly running. Yes, it is here error message, right? First error displayed, but second and third not displayed. So any error comes, script stops. Any error comes, interpreter stops here. Okay, see how it's working. Let me explain clearly how interpreter working. How interpreter is working. How interpreter is working. Suppose these are yes Python script statements. Script statement. First statement A equal to 10. First statement A equal to 10. Next statement yes B equal to 20. A equal to 10. B equal to 20. C equal to A plus B. C equal to A plus B. Not displaying C value. Print C value. C equal to A minus B. Print C value. Print C value. C equal to A into B. C equal to A into B. Yes, print C value. Right. So this is script. So it's a Python. Yes, same our script, just like our script. Just like our script. Okay. Yes, our script. These statements. Imagine these statements. These statements here. Okay, right? Yes. How interpreter is working? First statement A equal to 10, next is B equal to 20, next equal to C equal to A plus B, print C, C equal to A minus B, print C, C equal to A into B, print C. That's it here. Now, interpreter checking for the first statement. The interpreter checking for the first statement. Suppose first statement is correct. If first statement is correct here, yes, it converts first statement into binary code. 1 second. Yes, it converts first statement into binary codes. First statement into binary codes. Zeros ones format. Zeros ones format. Okay, so the statement converts into binary codes. Yes, that binary codes given to processor. That binary code given to processor. So processor taking binary code and generating out. Generating outputs. Okay, so interpreter check for the first statement. If first statement is correct, immediately converts into binary code. That binary code given to processor generating output. Okay, after that, checking for next statement. Checking for next statements. Suppose next statement also correct. Next statement also correct. Next statement also correct here. Then simply same converts into binary code. Zeros ones format binary code. That binary code given to processor. That binary code given to processor. Next, processor. So processor taking that code here and executing generating output. Generating output. Right? Yes. First statement checking. If first statement is correct, immediately converts into binary code and generating output. See, next statement may be right or wrong. Interpreter never think about next coming statements. Okay. Yes, interpreter, it won't check for next coming statement. Suppose the statement is correct. Yes, immediate execution generating output here. See, next coming statements may be right or wrong. Okay, interpreter never yes think about next coming statements. If the statement is correct, immediately converts into binary code and generating output. Okay, checking then execution. Okay, next checking for next statements. Okay, suppose next statement also correct. Next statement also correct. Simply converts into binary code and generating output. Next statement also correct. Simply converts into binary code generating output. Next checking for next statement. Checking for next statement. Suppose something wrong at the statement, something wrong. Simply interpreter stops. Something wrong, interpreter stops. See, any error comes, interpreter stops immediately. Any error comes, interpreter stops immediately. Okay, right? Any error comes, yes, interpreter stops immediately. That's it. So this working of interpreter. So interpreter way of working is like this. Okay, fine. Fine. So this is about interpreter. Okay. So interpreter checking line by line, checking first statement, then executing, checking next statement, then execute. It's a line by line. First line checking, correct. Execution completed. Means first line over. Next, second line checking. Second line also correct. Second line also correct. Simply converts into binary code, then execution. Checking, then execution. First statement completed. Checking, then execution. Next statement completed. Suppose any error comes, stops. Yes, interpreter shows only one error. Any error comes, interpreter stops. Any error comes, interpreter stops. Any error comes, interpreter stops. Yes, let me show same thing here. Yes. See here. So this is your script here. Okay. Yes. Now run this here. See. See 8th line error. Now correct that mistake here. 8th line. But this is the 8th line. So this here comma missing. Save. After saving. Then exit. Now let us run again here. Yes. Now next 13th line error. So what's happening? It's not showing all the errors at a time here. Only one error. Any error comes, interpreter stops. If any error comes, interpreter stops. Interpreter shows only one error. Okay. Now see this. Now let us correct this error also. Yes, correction of this error. So comma here, bracket missing. Bracket missing. Save and exit. Now again submit. Yes, next error. Next error. So we can see only one error at a time. Only one error. Only one error. Only one error. Okay. Yes. Next, this one. Yes, double quotation missing, right? Save. Switch. Now run it here. Yes, run it. Yes. Yeah, this is working of interpreter. So interpreter checking program line by line. Checking first line, then execution. So interpreter. Yes, line by line executes. Checking first line, then execution. Checking next line, execution. Okay, any error comes, stops. Any error comes, simply stops here. Interpreter shows only one error. Only one error. If any error comes, simply stops. It shows only one error. Okay, right? Next, compiler. Yes, how compiler is working? Compiler. Yes, let us see about compiler. Compiler. For compiler, yes. For this, I'm taking C programming. C program. Support test.c. C program. Yes, how compiler is working? How compiler is working? See, compiler checking for the first statement. Compiler checks the first statement. So first statement is correct. Statement is correct. Even correct, it won't convert into binary code immediately. Statement is correct. Even statement is correct, it won't convert into binary code immediately. No, it won't convert. Then checking for next statement. Suppose next statement also correct. Next statement also correct. Even correct, no, it won't convert into binary code. It won't convert into binary code. Okay. So checking for next statement. Suppose something wrong here. Error at third line. Yes, error at some line here. After checking for next statement also. Even error comes, it goes next statement. Checking for this. Next statement is correct. Then checking for next statement. Like this top to bottom. So compiler checks the whole program from top to bottom and shows all the errors. So first error at some line, next error at some line here. So checking for next statement, checking for next statement, checking for next statement like this. Okay. Compiler checks the whole program from top to bottom. Compiler checks whole program. Compiler checks top to bottom. Compiler checks the whole program from top to bottom and shows all the errors. But interpreter line by line, only one line checking. Correct, next one, execution. Next, correct execution. Next, something wrong, stops here. So interpreter is line by line. Interpreter is line by line, checking the execution, checking the execution. Any error comes, stops. It shows only one error. It shows only one error. But what happens? Compiler checks the whole program, all the lines from top to bottom, all the lines. Okay, all the lines, all the lines. Okay, all the lines from top to bottom and shows all the errors. And shows all the errors. So compiler shows all the errors. Compiler, it shows all the errors from top to bottom. Yes, let us see. Compiler, C program, compiler. Let us take C program example. A C program. Suppose here some C program. Yes, C program. Yes, this is Windows based C language. Yes, program to add, subtract. See, program to add, subtract and multiply two numbers. Multiply two numbers. Multiply two numbers. That header files, main function. Yes, reading two numbers and performing three operations: addition, subtraction, and multiplication. Same program. Same what we discussed in Python, same thing in C language. Okay, compile. Yes, compiling. Success. No error. No run it. Yes, first number 10, second number 20. Yes, addition 30, subtraction minus 10, multiplication 200. Yes, addition 30, subtraction minus 10, multiplication 200. Fine. Fine. Now, yes, some errors. Suppose there are some errors. For example, some mistakes. Suppose semicolon missing here. Suppose here bracket missing. Bracket missing, scanf here, comma missing. Okay, suppose here semicolon missing. Okay, suppose here double quotation missing. Okay, suppose here semicolon missing. Suppose here this bracket missing at the end. Yes, what happens here? No, saved. Now let us compile. Compile, see this. Total 11 errors. 11 errors. Press any key. Right? See this. First error. See at the bottom, 14th line. That math.cpp, 14th line declaration syntax error. 18th line error. 22nd line error. 25th line error. Yes, 27th line error. 29th line error. Okay. Yes. Next 30th line error. 40th line error. All the errors from top to bottom. Compiler checks the whole program from top to bottom. Compiler checks. Compiler checks the whole program from top to bottom. Checks all the statements from top to bottom and shows all the errors. And shows all the errors. And shows all the errors. Now let us correct all the mistakes here. Correction. Yes, semicolon missing. Okay. Yes, our bracket missing here. Okay. Yes. Suppose here double quotation missing. Okay, some missing statements. Okay, right? Yes, saved. Yes. All right. Now recompile. Yes, again still some more errors. Some more errors. 3 errors. Still errors. Yeah, 3 errors. Errors 3. See first one, 22nd line, 27th line, 30th line. 22nd line, 27th, 38th. So these 3 errors. Okay, now let us correct all the mistakes here. Just now here comma missing. Comma missing. Next here semicolon missing. Okay. Yes. Next here this semicolon missing. This semicolon. Yes. Now save. Saved. Yes. Overwriting. Compile. Success. Success. Compile. Successfully compiled. Yes. Program is success, right? Successfully compiled. Program successfully compiled. Success. Yes. After compilation, if no errors, what happens? Let us see. Suppose no errors. Everything is fine. Everything is fine. No errors. If no errors, what happens? Let us see. If no errors, everything is fine. Yes, everything is fine. No errors. If no errors, yes, if no errors, what happens here? If no errors, then compiler opens another file. It opens one more file, second file. Compiler checks whole program from top to bottom. It checks whole code from top to bottom, top to bottom. Suppose if no errors, compiler converts this whole code into binary formats. This whole code into binary format, right into another file. Binary format, zeros ones format. So next zeros ones format. Okay. So ones and zeros format, like whole code converts into binary format. And write to another file. And write to another file. Okay. Write to another file. Yeah, this file is called as exe file. Test.exe, test.exe. Yes, exe means executable file, executable file, executable file. Okay, right? Executable file. Okay, right? So this whole code converts into binary formats, generating one exe file. Okay, compiler checks whole program from top to bottom. If no errors, generating one exe file. Generating that test.c, test.exe file generates that exe file given to processor, exe file given to processor. So processor taking that exe file, generating outputs, executing and generating outputs. Generating outputs. Yes, let me show that exe file. Exe file. Where is that exe file? See. Yes, this is alt C. Compile success. See, name of the program file is math.cpp. Math.cpp. CPP and C language same. CPP. Math.cpp. See backend. In C drive, TC means turbo C. Here installed turbo C. Yes, there's a bin directory. In bin directory, all the programs. What is name of the program file? Math.cpp. Math.cpp. Math. That math.cpp file here. Math. Yeah, this is. One second, let me delete some of existing things. Yes, delete. Delete. Yes, see math.cpp. Math.cpp, right? Math.cpp. Okay, now this program. Yes, save. Yes, overwriting. Saved. After saving this here, no compilation. Compiles. Success. Now run it. When I try to run it, something happens back end here. Try to observe it here. Now, when I try to run this program here, something happens at the back end. Run it. See this. Yes, see. Some exe file, math.exe file create. Application means exe file. Application means exe file. See properties. .exe. .exe, right? Math.exe file. Application means exe file. So math.exe file created. Math.exe file created. Math.exe file created. After creating exe, now this exe executes. This exe file executing. See, now exe file running. 10, yes, 20, yes. That's it. Over. So this is working of compiler. So compiler checks whole program from top to bottom and shows all the errors. Compiler shows all the errors. Suppose if no errors, generating one exe file. That exe file contains complete binary codes. This whole code converts into binary format and write to another file called as exe file. So compiler generates exe file. That exe file given to processor. That exe file given to processor generating output. That's it here. Now, what's the difference you observed, guys? Tell me. Yes, interpreter and compiler. What's the difference you observed? Okay, 1 second. These two pages I'm placing side by side. Just observe this page. Observe this page. What's the difference you observed in these two pages? What's the difference you observed? What's the main difference between interpreter and compiler? What's the difference you observed? Tell me. Come on, guess. What's the difference you observed here? What's the difference you observed? What's the difference observed? Okay. Kiri Kishore, interpreter checks line by line. That's okay. Devidas, if compile finds error, it will create exe files. No, if finds error, no. If no error. Devidas, if no error, then creating exe file. Chiranjeevi, yes, we are muted. No, just you can share in the chat box. Chat box, our like chat box. Suppose if I unmuted, what happens? Because some background noise getting. It's unmuted. Okay, maybe some other from different attendees may be getting background noise. Cover that. Yes, muted everyone. Now unmuted. Now you can. You want now you can speak. Kavita, interpreter checks line by line.
Yes,
Compare.
yes, interpreter will go on the flow, like step by step it will go, whether it is the statement is an error or not, it won't, doesn't matter. So at the
Okay,
execution time, it will find the error.
that's okay, fine.
But
The thing is, this is
yes,
this page explained from.
yes, interpreter was like it will go the flow, like when they executing the statement, it will check whether it is statement is correct or not. So otherwise, I don't check whole file. But compiler first it will check top to bottom, then it will giving to the executable file.
That's okay, fine. That is common answer. Okay, that's common answer. But what's the difference? Exactly, what's the main difference?
Interpreter checks
What?
line by line.
That's okay. That's interpreter checking line when and compare checking whole program. That's okay. That's the difference. Okay, fine. See, just see the.
Interpreter stops
Interpreter checks one line, it
getting
converts to
error.
binary code.
No,
That's
sir. And say the major demerit is that interpreter stops there when it finds any error. It will not proceed ahead. But compilers
okay.
checks all. Then after it keeps a combined error list. Okay, these are the errors.
Okay, that's okay. Fine. One second. See, interpreter here in this page expand interpreter. In this page expand compiler. What's the difference you observed here and here? Two pages. The
Yes.
visual
So
showing the
interpret.
difference. With 1 second, with visual showing the difference. With visual showing the difference. See that visual. Yes, in first page, second page, what's the difference you observed here? See, these guys are saying correct. Prashant Kumar, good. Prashant Kumar, fine. Yes, Yakub also good. See, this is extra box, right? What is this box? Yes, this extra box in this second page, right? What is this box? It's exe file. Exe file. That is the difference exactly. Difference. See, interpreter does not generate exe file. Compiler generates exe file. That's the main difference. Okay, those are common answers. Yes, your college level and wherever you go, generally they will explain interpreter is line by line, compile is whole program. That's a common answer. Everyone says that, but exactly what's the difference? Exe file is a difference. That's the real
Sir,
time.
sir, can you please again explain it, sir, the difference?
Difference is exe file. Yeah, I'm repeating, don't worry. Yes, line by step by step, I'll explain. I'll compare, interpreter and compare once again. See here, this box right here, exe file created, but in case of interpreter, yes, first line convert into binary code, immediately executed. Second line convert into binary code and executed. So line by line, checking and execution. But in case of compiler, what's happening here? This whole code converting into binary format, writing to another file. It's creating another file, exe file. It's creating another file, exe file. See that? See, in case of math.exe file, right? In case of compiler, yes, compiler, yes, we observed one exe file, right? Exe file generated. Now go to Python scripting here. In Python scripting, what's happening here? Python scripting. See, Python scripting. Test.p only one file, right? Only our source code. Only source. Source means our program is a source code. Okay, our program is source code. This is called the source. This is called the source code. This is called the source code. Now this is called the source code. Source code. In Python scripting, only source code, right? No, running source code running directly. Source code running directly. Source code running directly. That source code running directly. But in case of C programming, what was happened here? Yes, one exe file created. One exe file created. The result is exe file. That exe file executing. So this is main difference. Okay, main difference. That's a real time. You'll see in real time only here. Yes, maybe learning in college level, learning maybe some institutions. Yes, anywhere. Okay, they will explain common answers like line variant and whole program. That's common answer. But when it comes to real time here, real time that's exe file. Okay, only real time guys can see that exe files. Okay, exe file that will generate exe file. So that will generate exe file here. Compiler based program generates exe file. Okay, now let me explain. So step by step differences. Yes, interpreter versus compiler. Let us compare this. Interpreter versus compiler. Interpreter versus compiler. Yes, interpreter versus compiler. See, interpreter versus compiler, the difference. Let us see the differences here. Interpreter versus compiler. So what's the difference here? First difference. Yes, it checks, interpreter checks. It checks code line by line. Line by line. Okay. Yes, next compiler. It checks whole program.
Whole program.
Whole program from top to bottom. Whole program from top to bottom. Top to bottom. Right? Top to bottom. Right? So whole program from top to bottom. First difference. Okay, top to bottom. Next. See, when output generating, yes, only one line output at a time. One line by line output here. Yes. Yes, it generates output line by line. See, line by line output. Line by line output. Line by line output here. In case of compiler, what happens here? First exe file
After total program.
Yes. Some exe file. Yes, exe file generating, right? Exe file. Exe file generating. That exe file executing at a time, right? So output at a time. So this at a time output here, at a time output. At a not line by line, at a time output here. That exe file executing and generating output. At a time output. That is at a time output. Okay. See, interpreter checks the code line by line. So interpreter checking code line by line. Compiler, it checks whole program from top to bottom. Yes, interpreter output is line by line, but compiler is at a time output here. At a time output. Okay, right? Next, suppose any error comes, interpreter stops. Okay, it shows only one error. 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 Compiler, yes, it shows all the errors, all the errors, all the errors, all the errors from yes, top to bottom, from top to bottom, from top to bottom. It shows all the errors from top to bottom. Okay, it shows all the errors from top to bottom. Okay, so interpreter shows only one error, but compiler shows all the errors, all errors from top to bottom, right? Yes, next. Yes, main important difference here. Yes, it does
In the
not
program.
it does not generate exe file. It does not generate exe file. Yes, exe file is a binary code file. Exe means executable. Exe means executable. It's a binary code file. Interpreter, it does not generate exe file. Compiler, yes, it generates exe file. It generates exe file. Compiler, it generates exe file. Compiler, it generates exe file, right? Okay. See, interpreter, yes, directly source code executing, right? Directly source code executing. See this. Directly source executing. Directly source code executing. Directly source code executing. Yes, it executes. It executes source code directly. It executes source code directly. It executes source code directly. Compiler, it executes exe file. It executes exe file. It executes exe file. Executes exe file. Okay, right? See, interpreter based languages are called as scripting languages. These are scripting languages. So these are called as scripting languages. Okay, interpreter based languages are called as scripting languages. Okay, see interpreter based Interpreter based languages are called as scripting languages. The interpreter based languages are called as scripting languages. Compiler based languages. See, compiler based languages are called as what? Anyone idea? Yes. Interpreter based language called as scripting language. Compiler based language are called as programming language. Programming and scripting. Okay, programming and scripting. There are some programming language, there are some scripting languages. Okay, so interpreter based languages are called as scripting languages. Compiler based languages are called as programming languages. Okay, programming languages. Okay, example. Scripting language examples. Python is the best example. Python is a scripting language. So for Python scripting, Python is interpreter. HTML, one more example. Hypertext markup language. HTML is a browser understandable language. Browser understandable language. Browser is an interpreter for the HTML. One second. Some HTML code. One Java HTML. See, suppose this is login HTML file. Open with the notepad. See, HTML by HTML. Between this form, they say form, login form. Here, this is login form. User ID, password. Login form. See this. Directly running. This is open. Directly running. Yes, no error checking, nothing. Directly executing. Source file execute directly. Yes, browser. It's open the browser, right? So it's a browser understandable language. HTML is a browser understandable language. Browser is an interpreter for this. Browser is the interpreter. For HTML, browser is an interpreter. So HTML this is. So in HTML, directly .html file executing. See, .html opened here. .html executed. No exe file. Directly .html executed. HTML file executed. No exe file. Okay, right? Yes, next. Yes, PHP is a scripting language. This is also one example. Next, Perl scripting. Okay, next, JavaScript. JavaScript is not a Java. JavaScript is different. Java is different here. JavaScript is a browser understandable language. Using with HTML. JavaScript using with HTML. So JavaScript and HTML combinations, we can develop the GUI, front end, web development. JavaScript and HTML using for the web development. Okay, means front end, web pages, that front end. Okay, right? Yes, Java different. Java is a server-side programming language. Server-side, maybe database access and different kind of things. So JavaScript is a browser understandable language. Java is a JVM understandable language. JavaScript working at the client side. Java working at the server side. Okay. Yes, next, Linux is shell scripting. So these are scripting language. Yes, programming language examples. C language, C++, okay, .NET. These are the .NET, C#. These are the programming language. These three are compiler-based languages. Examples. Compiler-based. These three are compiler-based languages. These are compiler-based. These are interpreter-based languages. Correct? Now, simply conclusion here. See, interpreter. Yes, interpreter. See, interpreter-based language don't have exe file. Interpreter-based language don't have exe file. Interpreter-based language don't have exe file. There is no concept of exe files in interpreter-based language here. Interpreter-based language don't have exe file. See here, yes, HTML, no exe file. Python scripting, .py for direct execute, no exe file. Okay, compiler-based file, everything is exe file here. Yes, So first of all, it generates, yes, here everything is an exe file. Everything is an exe file. Exe file. That's it. So these are differences. I hope everyone you understand the differences. Yes, guys, is it clear the differences? Okay, main
Yes, sir.
difference. This is exe file. Exe file is a main difference. Exe file is a main difference here. Okay, so compiler generating exe file, interpreter does not generate exe file. That's it here. Okay, see here. So generally here exe file, only who worked in real time they will observe the exe file. Simply, yes, college professors in college they are teaching, they will not observe these kind of things. Simply they will compile program, compile running. But real time is different and teaching is different here. Real time different and teaching different. Okay, real time different, teaching different here. See, exe file, compiler generating exe file. So after generating exe file, then execution. Okay, okay, fine. Okay, fine. Now here, yes, this MN Rao talking about everything. Yes, talking about Python, talking about HTML, talking about C, C++, this trainer, talking about all, very Java. Actually, our topic is Java, right? Yes, very Java. Java, is it interpreter based or compiler based? Yes, now we have to decide that also. We have discussed that also again. Java, is it interpreter based or compiler based? Let us see. See, I will explain about Java. Now let us start Java. Yes, I'm starting Java today. Yes, we are entering to Java now. Okay. Yes, Java. First, let me explain. I'll explain very clearly how Java program working. I'll explain clearly. Now you decide it. Java compiler based or interpreter based, just you decide it here. I'll explain clearly. After understanding, then you decide it. You come to some conclusion. Okay. Yes, first I will explain. I'll explain about how Java is working. Next, you decide it here finally. Okay. Yes. See, about let us start Java. See, except Java, except Java in other languages like C language or C++, okay, maybe Python scripting, except Java. In other languages, what happens here? What happens? First of all, source code converts into binary code. Source code converts into binary code. Okay, source code converts into binary codes. Yes, that binary code. Source code converts into binary codes. That binary code given to processor. So processor taking that code and generating output. This is what is happening in other languages, except Java. Source code converts into binary codes. That binary code given to processor, then executing, generating output. Yes, now come to Java. Yes, in Java, what happens here? Let us see Java. In Java, first of all, source code. Yes, source code. Now let us see Java program also. Source code converting to byte code. Source code converting to byte codes. Source code converting to byte codes. That byte code converting to binary codes. Binary code given to, yes, processor. Processor that taking that binary code, generating output here. Yes, in Java, what happens? There are two steps. See, other languages only one step. But Java, two steps. Source code converts into byte code to binary code in two stages. Java working two stages. First one is here, source to byte code to binary code. In Java, some byte code was introduced. Yes, byte code was introduced here. Why byte code introduced here? To make the Java as independent platform. Yeah, to make the Java as independent platform, bytecode was introduced here. To make the Java as independent of platform, bytecode was introduced here. Okay, source code to bytecode. Who will convert it? Let us see. Source code to bytecode. This is by the compiler. Yeah, this is by the Java compiler. Yes, let me show Java program also. Let me show one Java program. Yes. D drive. So let us take some test folder. Yes, this empty folder. D drive test folder, some empty folder. Okay, D drive test folder, it's empty folder. Yes, for Java actually we'll be using Eclipse daily. In our daily classes we'll be using Eclipse. See morning batch, collections topic. Okay, see, since last 1 week we started going on collections. See, first day demo, your first day demo for that collection, still collections going on. Topic. Yes, almost 6 days completed for this batch collections topic. Still it's going on because very, very important topic. See this Eclipse. See, in our regular classes, we'll be using Eclipse. Regular classes, daily classes, Eclipse. Eclipse using Eclipse only. Okay. Now, for simple and better understanding, I'm using Notepad. I'm using Notepad. Here I'm using a Notepad here. Okay. So command prompt. Just open command prompt. No D drive and test. You go to D drive, D colon, that will take to D drive. That will take to D drive. So that will take to D drive. So taking to D drive, right? That will be taking to D drive. That will be taking to D drive. Okay. 1 second. So mark this message, just a minute. Yeah. Okay. D drive, DER, test directory. Test change to test CLS, clear screen. Get DER, yes, test direct, nothing, 0 files, 0 files. Now let us take Notepad. Notepad, test.java, test.java file. Cannot find. Do you want to create? Say yes. Yes, now I'm writing Java program. Public class, simple program, public class test, public class test, class starting ending. Okay, next public static void main method string s caps square brackets args args string array of args. So main method starting ending. So between this system dot out dot println yes hello world hello world save and exit. Now dir c test.java 30th June. Okay, 10:11 a.m. Just now this is created. Test.java file created. Now we should compile it. Directly we can't run. Java program we cannot run directly. It has to compile. Okay, test.java. Okay, yes, compile. Java C means Java compiler. Java C means Java compiler. It's a Java compiler. Okay, now Java compiler. Yes, result is what dot class. So this dot class contains what bytecode file. Source code test.java is source. That source code converted into bytecode file. So test.java is a source. Test.java it's a source code converting into the dot class file means bytecode. Source to bytecode by the Java compiler. So compiler part is overwrite. Yes, 1 second. Suppose 1 second. Del start dot class. Del means deleting files. You see here I have deleted dot class. Just I have deleted dot class file. Start dot class. The dot class file deleted. Not dir. See dir. So test.java file. Now the notepad test.java file. Yes, see this. Suppose some mistakes. Bracket missing. Semicolon missing. Suppose this brace missing. Closing brace missing. Exit. CLS clear the screen. Now let us compare it. Up array key. I can get previous comments. Up array key. Previous comments. Yes. See all the errors on top. But it's a compiler. Right? Compiler checking for all the errors here. and shows all the errors. Okay, so here error, here totally 3 errors. Totally 3 errors. So compiler shows all the errors from top to bottom. No, that means here this is a compiler. Java C, it's a Java compiler. So compiler shows all the errors from top to bottom. Okay, all the errors from top to bottom. All the errors from top to bottom. Okay, now let us correct all the errors. Correction of these errors. Yes, semicolon and bracket missing. Correction. Save. And exit. After this, now see here. Don't have dot class, right? Because that still errors are there. If no errors, generating dot class file. Compiler checking whole program from top to bottom. If no errors, then it generates dot class file, not dot exe, dot class file, not dot exe. C language is exe file. In C language, compiler checking whole program from top to bottom. In C language, compiler checking whole program from top to bottom generates dot exe file. In Java also, Java compiler checking whole program from top to bottom. Java compiler checking whole program from top to bottom. Okay, if no errors, it generates one dot class file. Okay, C language and Java both are compilers here. Java compiler checking top to bottom, C compiler also taking top to bottom. The difference is C compiler generating exe file, but Java compiler generating dot class file. Dot class is not exe file. Exe is different, dot class is different here. So dot class is a bytecode file. Now what happens here? Java compiler checks the whole code from top to bottom. If no errors, generating one dot class file. Source code to bytecode by the Java compiler. Right? Okay. Fine. Now here source code. Source code. Yes, it's a test.java file. Test.java file. The test.java file given to Java C compiler. That's given to Java C compiler. Java C compiler taken here. If no errors, then generating bytecode. Then bytecode. It's a bytecode. Tested dot class file. Tested dot class file generated, right? Tested dot class file. Okay, right? After that, next what happens here? Now, yes, dear. See, now tested dot class file. Got it, right? Now this tested dot class file has to execute Java test. Yes, hello world. Now what is this Java? See, Java C means Java compiler. Java C means Java compiler. Now what is Java? It's the interpreter. This is the interpreter. Now tested dot class is a dot class file taken by the interpreter, converting that code line by line. Yes, in dot class is a bytecode. Yes, now interpreter taking bytecodes, converting to binary code line by line, then generating output. So from tested dot class file here, interpreter taking first line, converting to binary code, then execution. Second line converting to binary code, then execution. Third line converts into binary code, then execution. Okay, right? So execution by the interpreter. So interpreter taking bytecode file, converting into binary code. So this part bytecode to binary code. Yeah, this part by the Java interpreter. This part by the Java interpreter. This part by the Java interpreter. Okay. Yes. Now bytecode file. This bytecode file given to Java interpreter. So given to Java interpreter. Now this interpreter is taking dot class file, converts into binary code. Result is binary code, right? That binary code given to processor, right? Binary code given to processor, only generating output. Okay. So what is happening here? Yes, in Java. See, in Java, errors checking by the compiler. Error checking by the compiler. Right? Error checking by the compiler. Okay. Yes, program execution by the interpreter. Program execution by the interpreter. Okay. So error checking by the compiler. Suppose if it is C language, error checking by the compiler and exe file also creating by the compiler, then execution by the compiler. So here everything by the compiler. C language all are by the compiler. Python everything by the interpreter. But when come to Java, in Java errors checking by the compiler. If no errors, generating dot class file. That dot class file given to interpreter. Now program execution. The Java program. Okay, Java program execution by the interpreter. Execution by the interpreter. Okay, see here. So first what happens here? First compilation. First step is
Which file is binary code here? Test.
1 second. Yes, here DR. So first what is first step? Notepad test.java. Notepad test.java. Test.java, right? Test.java code is this. So this is test.java code. Okay, test.java code. Now this is compiler compiles. Okay, compiled. After compilation, result is what? Test.class file. Test.class. 10:19 AM. Now time is 10:19 AM. Just now generated. Dot class file just now generated. Now Java test, right? Yes, hello world. So first one is Java compiler program checking, error checking with Java compiler generated dot class file. It's a bytecode file. That bytecode file is given to interpreter. What happens? Interpreter taking line by line, converting bytecode to binary code, then executing immediately. First line converting, executing immediately. Second line converting, executing immediately. Third line converting, executing immediately. It won't generate one more exe file. It won't generate any binary code file. No binary code file generating. What is interpreter? How interpreter working? How that interpreter working? Yes. See, Java interpreter taking that bytecode, converting to binary code and given to processor. Line by line. Execution runtime is line by line. It won't write to any other file. That binary code won't write to any other file here. Binary code there. What is interpreter? Interpreter converting then execution, converting execution. It won't write to another file. Yes, here Java, see Java compiler converting .java to .class file. Java compiler generating one .class file. It's a bytecode file. That bytecode file taken by the interpreter and converting to binary code line by line and executing immediately. It won't write to another file. There is no binary code file. Just only bytecode file, source code, bytecode and program execution directly. No binary code file here. No file, just a conversion to binary code. That's it here. See what happens here. Just converting into binary code. Okay. See line by line. Java interpreter taking test.class file. First line converting to binary code and given to process then execution. Second line converting to binary code and given to process then execution. Here don't have any binary code file. Only source code, bytecode. Only source code and bytecode. That's it here. I think you understand, right? Test.java is a source code. Test.class a bytecode file. Okay, right? Now tell me, Java depends on what? Is it compiler based or interpreter based? Now tell me.
That means no binary code means no .exe file.
No exe file in Java. That is my question I should ask actually. Just wait for some time. Yes, now tell me, Java, is it compiler based or interpreter based? What do you understand? Come on guys. You can ping in chat box or else you can speak. You can speak or you can ping in chat box. Yes, Java. Yes, it's a both. Java depends on both here. Java. Yes, Java is compiler based. Java is compiler based as well as yes, interpreter based. Both here. Compiler depends on both here. Interpreter based. So compiler both here. Compiler depends on both here. Java is a compiler as well. Yes, interpreter based. Compiler as well, interpreter based. Okay, right? Now here's some question for you guys. Some question now. Now this is cleared. So Java is a compiler as well, interpreter based. Java is a compiler as well, interpreter based. Okay, fine. Some question for you guys. Yes, can we create exe file in Java? That's a question. Okay, or yes, is there any exe file concept in Java. Concept in Java. Tell me what you understand from this explanation. Can we create exe file in Java?
No exe file.
Yes. Have you observed any exe file? No exe file. Dot Java is a dot class file is here. So this is that bind the code. It won't write any result file. Bind the code directly execution. Line by line converting to bind the code then execution. Line by line converting then execution. It won't write any result file. No exe file. It won't generate any exe file. See, yes, steps. First step is notepad. Next step is compilation. Next step is execution, right? 3 steps. Yes, in these 3 steps, yes, anyone observed .exe file here? Anyone observed .exe file? You guys, anyone? You guys, no exe file. No exe file. Yes, Java don't have exe file concept here. Okay. Yes, no, we can't create. Okay. Yes, do Java. Yes, don't have. Yes, Java don't have concept of exe files. Yes, Java don't have concept of exe files. Exe files. Okay. Reason why exe file? Yes, why Java don't have exe file? Reason Java is independent platform. Yes, to make the Java is independent platform, that exe file concept eliminated in Java. To make the Java independent platform, that exe file concept eliminated. That is tomorrow topic. Tomorrow, how Java made us independent platform. Tomorrow topic is very interesting, no doubts. Okay, tomorrow topic is very interesting topic here. Okay, tomorrow topic, don't miss it. Don't miss the tomorrow topic. See, you guys maybe joining to my batch or not, that is secondary. But don't miss tomorrow class. Tomorrow class, the topic you will not see anywhere. Worldwide, any website will give that kind of explanation, that kind of information. No Java trainer will explain that kind of explanation. I'm sure it's my challenge also. See the tomorrow class. See the tomorrow class, that way of explanation. That class, yes, you will see wonderful class. Tomorrow you'll see wonderful class. Okay, try to attend it. Okay, maybe joining or may not be joining. I don't mind. That's your wish. Okay, tomorrow don't miss it. Okay, yes, in Java don't have exe file. Java don't have exe file. Exe file concept here. The Java don't have exe file concept. There's no there's no concept of exe files in Java. Okay, Java don't have the concept of exe files. Next one more thing here. One more thing here. See, any language program execution by the interpreter. Any language program execution by the interpreter. Yes, interpreter. Yes, don't have exe file. Simple. Don't have exe file. Don't have exe file. Okay. See, any program execution by the interpreter. No exe. Suppose errors may be somebody checking. Errors may be somebody. But runtime program execution by the interpreter, no concept of exe file. If program executing by the interpreter, any language program, any language program execution by the interpreter, no exe file, don't have exe file. Okay. Yes, not Java. Java, yes, who will execute Java program? Interpreter. Interpreter will execute, right? Yes, since Java dot class file, executing by the interpreter, yes, interpreter. Since yes, Java program execution, Java dot class file executing by the interpreter, don't have exe file in Java. Don't have exe file in Java. Don't have exe file.
Sir, similarly, Python, all those things are done by interpreter. So those are also platform independent.
Yeah, Python I'll explain. Tomorrow we'll compare the Java and Python. Python is independent platform.
Sir, one more doubt. In Python, no file is going to create, right?
Python, it won't create in exe file. Directly source code executes.
Okay, but here it will create a dot class file, right?
Dot class file. Why this dot class file is to make the Java is independent platform. Why dot class file concept introduced here? To make the Java is independent platform. That is tomorrow topic we'll discuss. So why
Okay.
dot class file introduced in Java? Why dot class file? To make this Java is independent of platform. To make this Java is independent of platform, dot class file was introduced. Okay. Yes, fine.
Okay.
Here,
Thank you, sir.
yeah. So here Java don't have exe file concept. In Java, everything, yes, in Java everything is a dot class file. Java everything is a everything is a dot class file. Dot class file. Okay, see, dot class is not exe, but dot class is different, exe is different. Dot class file is not an exe file. Dot class is not an exe file. Okay, exe file is different, dot class is different. Dot class is not exe file. See, is a exe file is a binary code file. Exe file is a binary code file. Binary code file and it's a system understandable language. It's a system understandable language. System understandable language. Understandable language. Okay. Next, what is dot class file? Dot class file is a bytecode file. It's a bytecode file. It's a bytecode file and it's a JVM understandable language. It's JVM understandable. Bytecode is a JVM understandable. That is not a system understandable. Okay, JVM understandable language. JVM understandable language. JVM understandable. JVM understandable language. Okay, right? JVM understandable language. Okay, next one more. exe file. exe file. exe file is an OS dependent. Yes, the topic tomorrow. OS dependent. Yes, dot class. Dot class file is an independent of OS, independent of platform, independent of platform. Okay, yes. Now this topic tomorrow. Why exe file is OS dependent? Why dot class file? How dot class made us independent of platform? Okay, yes. Java features. Now we can understand Java features. D drive, Java, yes, 9:50 AM. See day 2. On day 2, list of Java features given, right? Now we can start now. Java features. Now we can understand here. Okay, now we can understand independent of platform portable. These features now we can understand. See, last 2 classes, yesterday class and today class is a prerequisite to understand these Java features. For some basics, the basics are very, very important. So without basic knowledge, directly if I take into Java features may not be understanding. Okay, tomorrow we'll see. Yes, what's the advantage of last 2 classes? Yesterday class and today class. Yesterday and today class, these basics. What's the use of these basics? Tomorrow class, in tomorrow class, you see that, you'll feel that here. Yes, tomorrow class, you feel that last 2 classes are very, very important. Tomorrow, you feel that. So today's class, yesterday's class, very, very important for Java understanding. That's the reason taken some basics. That's it here. Yes, any doubts, guys?
Sir,
Tell me.
I want to know what exactly is a bytecode.
Yeah, we'll discuss. In Java programming, I'll explain. So this is not right time. What is bytecode exactly? In Java programming, we started Java programming. That time we can see practically. I'll show that. Okay.
Okay.
Right. This is not right time. Yes. Next.
Okay, sir.
Any doubts? Yes. Tomorrow class, don't miss it. Don't miss it. Tomorrow class. Tomorrow class is very, very important. Don't miss it. Tomorrow class. Tomorrow class, don't miss it here. Okay. 1 second. Yes. Still anyone not share your details in WhatsApp? Yes, 1 second. Let me show that WhatsApp group. See, in WhatsApp group, yes, all the last 3 days session shared already. Last 3 classes. Yes, class document shared as well. Recording also shared. Okay, just to see that recording. Yes, today's recording also I'll share in the WhatsApp. Yes. I think for some guys already access given yesterday night. Yeah, today I'll give the access now. Still any members are there, I'll give the access today. Today by 12 o'clock I'll give the access.
Excuse me, sir.
Yes, I'll check with the online team. I'll give the access. Yeah, tell me.
Yeah, Even I paid the fee, sir, but I didn't get any recordings in the drive.
Yeah, definitely. I'll check it on and just now.
Yeah, that's good. You will get the information, right, sir? Or shall I inform them again?
It's not necessary. It's not necessary.
Okay, sir.
That online team will come to office. Yes,
Okay,
online
sir.
team
Okay, then.
9 o'clock.
Yeah, even I checked the drive, but I didn't get any of your recordings, so that's the reason I got the doubt.
Yeah.
Okay, sir.
So see, this is last class shared. See here, session 1 and document, session 2 document, session 3 document. All of this is shared in the drive. Sorry, shared in the WhatsApp group. Yes, drive access. Today I'll give the drive access now. I'll give the drive access. Okay. Yes, WhatsApp group. How many members join into group? Yeah, 23 members. Yeah. Yes, still anyone? Yes. Can you share it? This is my WhatsApp number. Yes, 817-189-123. Yes, share your name and your Gmail enough. Name and Gmail ID. I will add the group. Okay. Not only group communication. Yes, you can communicate with me individually also. Yes, anyone wanted any information? Yes, anytime you can communicate with me. Yeah. Okay, fine. Yes, that's all for today. Yes, same link for tomorrow also. Yes, we'll continue for tomorrow. Yes, we'll continue for tomorrow. So thank you guys. Yes, see you tomorrow. Have a great day. Have a great day. See you.